In this graph, we see a scatter plot with the blue dots, and then a purple line is the line of best fit for that data. In other words, we're trying to get an equation that explains that data. Here's the equation right here. So 1.79 plus negative 2.15x, etc. At the end, we see this r squared value. Now, an r squared is a statistical measure of how close the data are fitted to the regression line. It's also known as the coefficient of determination. And so it's basically, if that value is 100%, in other words, 1.00, then it says it explains all the variation in the data. Now, this line is actually a very good fit for this data, but it doesn't explain all the variations. So you see variability like this dot is not on the line, nor is this one. In fact, most of them are not directly on the line itself. So how do we get this this best fit and this r squared value, this measure or coefficient of determination? So here we have some data for the time and the distance of this car. So here's my car, Chevy Volt, and I wanted to see exactly how far it has gone after a certain time. So, and then to plot that. So I'm going to click on the first cell, then shift click on the last cell in that block, and then go ahead, I'm going to plot this. So here now is a plot of that data. So we're going to put it into a scatter plot. So we're going to check on the format there and choose a scatter plot. And now we want to put in the line of best fit. That's going to come under the Customize tool. So you can click under Customize here, and it's going to be customizing the series. In other words, the series of points referred to in column B as distance. It's going to click on that right there, and then you'll notice that there's an option down here that says Trend Line. So when you select Trend Line, we can choose trend lines of various different forms. So we're going to show the r squared value right here. We can see the r squared value is 0.936. That's for a linear trend line. What we're going to do right now is we're going to change it from linear here to exponential, and the value increases to 0.964. So there was 96.4% of the variability. So it's definitely a better fit. We can then try polynomial, and we're into 98.9%. So it appears as though a polynomial function, which you would expect it to be with a standard accelerator on your car. And now we want to put this into its own graph. So we click on the three dots. We're going to say we'd like to move to its own sheet. And now we have a graph here which shows the line of best fit as a polynomial expression. And we can see the r squared value, but we still don't have the equation. So if we go to edit the chart and go back to customize, and under the series, a series of data points, we'll notice that there's another option right there to give the data labels, and also to give the equation for that form. So we're going to click on here. We're going to say use equation. There's the equation. It's under label. And so now we can see there's the actual formula for this best fit polynomial line to describe that data.